So, shifting gears a bit from physics to Einstein to Sir Arthur Clarke. His work ranged from scientific discovery to science fiction, from technology to entertainment. He was an engineer and a futurist and a humanist who influenced artists, scientists, and engineers. Did Arthur Clarke influence you in your pathway or growth as you became a futurist or a scientist or a thought leader?
Yes. You see, when I was 8 years old, I was fascinated by Einstein's unified field theory, this cosmic quest to unify all the laws of nature. But on Saturday mornings, I used to watch television, specifically Flash Gordon. And I saw a whole new world out there, a world of ray guns, space monsters, cities in the sky, invisibility, and I was hooked. I was hooked. I had to know more and more about this world of science fiction. And then, reading the work of Arthur C. Clarke, I began to realize that my two passions in life, one, theoretical physics, and two, the future, were really the same thing. That in order to understand what is possible, what is impossible, what is plausible, you have to understand physics. Physics tells you whether or not you can have ray guns, flying saucers, invisibility, all the things that you see in science fiction. How do you tell whether they are really partly fact or partly just fabrications? That's where physics comes in. And that's one thing I liked about Arthur C. Clarke's work. Sometimes I think science fiction gets too much into fantasy and magic. No rhyme or reason. You have to have a plot twist. Boom, you just create whatever out of fantasy. But no, Arthur C. Clarke tried to root many of his fantastic ideas to the known laws of physics. And I think that's really important. So, for example, when I see the movie 2001, I say to myself, how realistic is this movie? And then I begin to realize that of all the science fiction movies that I've seen about encounters with alien life, the movie 2001 is perhaps the most authentic, the most consistent with the known laws of physics. You see, in the movie 2001, there is something found on the moon. There's a monstrosity on the moon. What is it? They sent astronauts to find out. Well, in physics, we have something called a self replicated von Neumann probe. A von Neumann probe is a robot. It lands on a planet or a moon. Moons are most likely because, of course, they're stable, no erosion, no rust on the moon, and they replicate themselves. They make copies of themselves. Starting from one robot, you have 1,000, and then they shoot out. They shoot out and colonize other moons and other planets, and they create more copies of themselves. And so we have this exponential explosion of these robotic probes. And what is that? That is the basis of the movie 2001. That's the most realistic encounter with intelligent life in the universe. Now, some people think that Captain Kirk and the Enterprise, that's the way you explore the galaxy. But there are just too many stars out there, too many planets. How can we explore all of them with the Starship Enterprise? You can't. But what you do is you have self replicated von Neumann probes. They make copies of themselves. And where have you seen that before? That's a virus. That's how Mother Nature also explores your body. And after 2 weeks, this molecule called a virus gives you a cold. So the movie 2001 is actually the most scientifically accurate description of how we might encounter intelligent life in outer space. Don't expect a flying saucer to land on the White House lawn and somebody comes out and says, here I am. I'm here to give you all the benefits of an advanced civilization. No, the exact encounter with an intelligent life form may be to encounter a von Neumann probe, a robotic, self replicating probe, which is by far the easiest way to scan the entire galaxy. Traveling near the speed of light, this probe could pretty much colonize the entire Milky Way galaxy and explore all the mysteries of the galaxy within about 100,000 years. And so we realized that Captain Kirk, yeah, he was the one who soared into outer space with the Enterprise, but that is the most inefficient way to explore the universe. If you want to see the most efficient way to explore the galaxy, see the movie 2001 with new eyes.
That's interesting because Arthur Clarke also said that any type of advanced technology is indistinguishable from magic, as you mentioned, right? He famously predicted geostationary satellites, the internet, telemedicine. As a futurist, what type of magic or advanced technology, depending on your perspective, do you see in the future of mankind, in the future of the earth, beyond that? How do you see the future turning out?
Whenever I see a science fiction movie years ago, I used to count how many laws of physics they violated. After a while, I begin to realize this is no fun because the fun of a science fiction movie is to go a little bit beyond the known laws of physics. So, for example, when I see Harry Potter, most people would say that's just magic. But I ask myself a different question. How many laws of physics are violated in a Harry Potter movie? And then I go back to Arthur C. Clarke's quote: any sufficiently advanced technology is indistinguishable from magic. If that's true, if what Arthur C. Clarke said is true, then much of what we see in Harry Potter movies is within the laws of physics. And then I begin to realize that if you have nanotechnology, if you have the ability to manipulate individual atoms, and we physicists are closing in on this ability, then perhaps much of the magic you see in Harry Potter is nothing but nanotechnology, manipulating atoms one for one, creating things that are normally impossible, but well within the laws of physics. The ultimate nanotechnologist is Mother Nature. Mother Nature is a nanotechnologist. And then looking at a Harry Potter movie with new eyes, the eyes of Arthur C. Clarke. If you have a replicator, you could literally pull a rabbit out of a hat. What is a replicator? A replicator is a machine that takes raw atoms, reassembles them atom for atom. And so if you have a replicator, you could simply replicate all the magic of Harry Potter. And is it possible to build a replicator? Well, we physicists think so. Of course, it would be very difficult, maybe another 100 years. But hey, 100 years is nothing compared to science fiction. And so the point I'm raising is the magic you see in Harry Potter could, in some sense, be duplicated by the magic of the world's greatest technologist, Mother Nature. And if we have a replicator, we too could become Harry Potter.
It reminds me of other topics or leads to other topics that I've heard you discuss, ranging from starships to time travel, black holes, wormholes, alien civilizations, hyperspace, antimatter drives, and parallel universes, which in fact I found is the lead sentence for a course abstract that you currently teach at the City College of New York. It's titled The Physics of Science Fiction. So I thought I'd shift to some topics on science fiction, specifically where quantum physics and popular science seem to intertwine ever since H.G. Wells penned The Time Machine in 1895. So many genres have shown time travel, from a phone booth to a spaceship to a hot tub. So I wanted to ask, do you know, what's your opinion on what scenario is time travel possible? Through a black hole or something man-made?
Well, it turns out, believe it or not, we have several different designs for a potential time machine. In the late 1940s, Einstein's next door neighbor, Kurt Gödel at the Institute at Princeton, found a solution of Einstein's equations which allowed for time travel. This is an Einsteinian solution, not simply some kind of crackpot idea, but a solution of Einstein's equations which allow for time travel. If the universe rotated and you went along with the rotation, you could come back before you left. Time travel is possible in a rotating universe. Now, Einstein was very deeply concerned about this. He thought that's nonsense. And in his memoirs, Einstein wrote that you can dismiss this idea of time travel on physical grounds. In other words, the universe doesn't rotate, the universe expands. So, this means that if the universe expanded and rotated, then perhaps time travel will be commonplace. Since then, we found many other solutions of Einstein's equations which allow for time travel. You mentioned black holes. Under certain circumstances, black holes could become a tunnel. a tunnel through space and time, allowing you to connect here with the past. And so the river of time, we thought, was uniform. Newton, for example, Isaac Newton thought that time was like an arrow. You fire the arrow, it never deviates. Einstein says, not so fast. The river of time is a river that speeds up and slows down. The new wrinkle in all this is that we think the river of time can fork into two rivers, and the river of time can have whirlpools in the river of time. Now, what's the catch? There's always a catch someplace there, right? Otherwise, we would have time travel yesterday. The catch is you need fantastic amounts of positive energy, like a black hole, to open a hole in space and time. Then you have to have negative energy to stabilize it so it doesn't collapse on you when you walk through. So Stephen Hawking actually mathematically codified what is necessary to build a time machine. It would require a technology millions of years more advanced than us, a technology incorporating black holes and stars, but it might be possible. It can't be ruled out at the present time. Now, how do we resolve the paradoxes of time travel? If you go backwards in time and meet yourself as a child and you shoot yourself, how can you commit suicide in the past when you are an adult in the present? It's a paradox. The way around the paradox is when you go backwards in time, the river of time forks into two rivers. And what you killed is somebody else, not yourself. So if you go backwards in time to save Abraham Lincoln from being assassinated at the Ford Theater, you rescued somebody else's Abraham Lincoln. Your Lincoln died. That cannot be changed. But the Abraham Lincoln of this parallel universe can be saved. This is called the multiverse idea, which, believe it or not, most physicists adhere to. A multiverse idea that says the river of time can constantly fork into parallel universes. And then the next question that I often get asked is, if the multiverse idea allows for parallel universes, and it's one of the leading theories of the quantum theory, then is Elvis Presley still alive in a parallel universe? Well, the answer is, yeah, probably yes. That if the river of time can fork, there's probably another universe out there where Elvis Presley is still belting out those hits, hit after hit, but not in our universe. Sorry about that. That universe has split off from our universe. So don't expect to be able to talk to dead people anytime soon.
Do you have an opinion of what movie or work of science fiction might be close to feasibly explaining time travel? One that comes to mind is the movie Interstellar, which I believe was based on the work of a theoretical physicist as well, maybe a Nobel Prize laureate.
The movie Interstellar, Kip Thorne at Caltech, winner of the Nobel Prize, was one of the consultants on that film. And by the way, when the film ends, it ends on string theory. You see, string theory says that our three-dimensional world is really a tiny piece of the real universe, which is hyperdimensional, up to 11 dimensions. And so in the final scene where Matthew McConaughey is seen floating in a hypercube, that hypercube comes from string theory. Now, I'll be very clear about this. String theory is not proven yet. We hope one day it will be proven, either mathematically or by an experiment, but it's still something that is quite a matter of debate. Nobel Prize winners argue on the question for and against string theory. So it's not a definite thing. However, in the movie, they took a certain amount of liberties and ended the movie on string theory.
Conversely, to a movie that gets it right, do you have any opinions on any works that get it hilariously wrong when it comes to time travel?
I think most movies sort of get it wrong. However, I think Back to the Future at least made an attempt, and also the latest Avenger movies, believe it or not, try to get it right. In Back to the Future, when they go back into the past and as the universe splits in half, Doc Brown goes to the blackboard. He goes to the blackboard and draws a horizontal line representing the timeline of the universe. And then he writes a fork in this line where the universe branched off into a parallel universe. That comes from physics. That's how we physicists represent parallel universes. And that same diagram of a line splitting in half is found in the latest Avengers movies. That's right. When the rampaging Hulk meets a guru, the guru draws the river of time and then has the river of time fork into two roads. And that's the multiverse idea, which is now one of the hottest ideas in Hollywood. That's right. You can't move in Hollywood without bumping into the multiverse idea. Loki, for example, the god of mischief, lives in a different plane caused by the forking of the river of time. So here we have Hollywood trying to catch up to modern physics.
That's amazing. And it reminds me of another observation from Arthur that there are two possibilities for us as humans. Either we are alone in the universe or we aren't. And he said both are equally terrifying. So I thought I'd ask what your views are on extraterrestrial life, overcoming the Fermi paradox, getting past the great filter, and maybe we might be better off not inviting an alien invasion through trying to communicate. I mean, where do you stand on how we exist in the universe with other life?
On average, every single star you see at night, out of 100 billion stars in the Milky Way galaxy, every one has a planet going around it. And maybe 20% of them have Earth like planets going around them. Think about that. Billions and billions of Earth like planets in our own backyard. And to think that we're the only game in town, I think is rather presumptuous. However, we have to be cautious because, well, look what happened to Montezuma of the Aztecs when they met Cortez in Mexico City. Montezuma made the biggest mistake in ancient history. He assumed that Cortez was a god. Nope, Cortez was a bloodthirsty pirate hungering for gold. And that meant he would literally destroy the entire Aztec empire. So I think we have to be cautious encountering intelligent life in outer space. We should first listen in and find out what their intentions are, find out the level of their capabilities, and what goals they may have. And of course, science fiction is full of these stories. Take a look at War of the Worlds. In War of the Worlds, what did the aliens want? They didn't want gold. They didn't want riches. No, they just wanted the Earth. They wanted to take over the Earth. And the Martians didn't hate us. The Martians didn't dislike us. No, we were just in the way. And we had to be removed so that the Martians can take over the Earth. And take a look at Star Trek. Look at the Borg. The Borg, well, they don't want gold. They don't want minerals. What do they want? Our mind. They want to take over our mind. That's what the Borg wants. So I think we have to be cautious. Now, I'm all for SETI, the search for extraterrestrial intelligence in outer space. I'm all for that. We should eavesdrop on alien conversations. But I don't think it's a good idea to advertise our presence and say, here we are, folks. Here we are. Come visit us. Nope. I think that is a huge mistake.
On the topic of science, there's also another quote that I'm reminded from Arthur Clarke. He once said that it may be our role on this planet not to worship God, but to create him. So I thought I'd ask quite simply, do you believe in God, or do you think the answer is more closely related to Sir Arthur's point of view?
I adhere to the God of Einstein. Einstein was asked many times, did he believe in God? And he said, well, let's be careful. There are two kinds of God. So which God are you talking about? First is the personal God, the God that you pray to. You want that bicycle for Christmas? You pray for that bicycle. You want to smite the Philistines? Well, you pray to God to smite the Philistines in the next battle. Einstein did not believe that the creator of the universe created the universe just so that we could fulfill our dreams at Christmas time. No, he did not believe in a personal God. He believed in the God of Spinoza, the God of order, harmony, beauty. The universe is gorgeous. The universe is fantastic, but it didn't have to be that way. The universe could have been ugly, chaotic, random. It could have been just a bunch of subatomic particles in the mist of time doing nothing, creating nothing. But here we are. Here we are in a gorgeous universe, a universe where on a single sheet of paper, you can summarize all the known laws of physics. It didn't have to be that way. It could have been chaotic, messy, crude, and yet here we are. He likened himself to a young boy visiting this huge library for the first time. Books upon books, row upon row of knowledge, and all he could do was take the first book, open it up to the first chapter, and read a few paragraphs in the first page. And Galileo was also asked a similar question. And Galileo's answer was this: the purpose of science, he said, is to determine how the heavens go. The purpose of religion is to determine how to go to heaven. So, in other words, religion is about ethics, how to be a good person, how to go to heaven. That's what religion is about. Science is about natural law. It's about planets and galaxies and atoms. It's about natural law. And he said, as long as we get these two clearly separated, they're complementary. There's no problem. The problem arises when somebody from the sciences begins to pontificate about ethics and religion, or someone from religion begins to pontificate about natural law. That's when we get into trouble. But as long as we keep these two things apart, they're complementary. They're not in contradiction with each other.